So good afternoon to all. Okay, so first upon I will revise the point. Okay, whatever point we have covered in that last lecture, and then we will move toward the today's next point. Okay, in that last part we have covered the following parts like this: what is meant by the limit. Okay, then what is meant by the upper limit and lower limit. Okay, then what is meant by the tolerance. Okay, what is meant by the tolerance? Tolerance is nothing but it is the permissible variations. Okay, again it having two types. One is the unilateral. Okay, unilateral, and the second it would be the bilateral. Okay, bilateral. Bilateral and unilateral means what? That unilateral is nothing but when we are showing the tolerances on the only one side of basic size. Either we have to show on the plus side or either we have to show on the negative side. Example 30 minus 0.02 minus 0.01. It is unilateral because here only one side, only negative side we are showing the tolerance. Suppose 30 plus 0.02 plus 0.01. Again, it is the unilateral tolerances. And when we are showing the tolerance on the both the side of basic size, means when we are showing the tolerance on the plus side as well as in the negative side, then it will become the bilateral tolerance. Means 30 plus 0.01 minus 0.01. Here we are showing the tolerance on the upper side and the in the negative side also, means like this. So this is the zero line. Okay, and your tolerance zone, it will be like this. Okay, it is called as the bilateral tolerances. And unilateral tolerances is nothing but like this. Either we have to show on the below the basic line or upper the basic line. Okay, see, these are the simple unilateral tolerances and bilateral tolerances. Then what is meant by the deviation? Deviation is nothing but it is the algebraic difference between actual size minus basic size, na? Yes, it is correct.
Yes, sir.
Okay, then what is meant by the upper deviation? Upper deviation is equal to upper limit, okay, minus basic size, na? Basic size. Then lower limit is equal to, or lower deviation is equal to lower limit minus basic size. Okay, then what is meant by the allowance? Allowance is nothing but it is the difference between, yes,
Two mating parts.
two mating parts. Okay, then again what is meant by the zero line? What is meant by the zero line? Zero line is nothing but it is the graphical representation of basic size. Means your zero line, it will showing the exact basic size. Okay, in upper side it will be the positive side. Okay, above the basic line there will be the positive, and below the basic side it will be the negative. It will be increasing manner, it will be decreasing manner, like this. Okay, then again which point we have covered in that last lecture? Yes, yes.
Fit.
Anyone? Okay, what is meant by the fit? Okay, then tell me what is meant by the fit. Fit is nothing but it will indicate the relationship between two mating parts. Okay, or we can say it will show the tightness and looseness between two mating parts. Okay, so it is called as the fit. Okay, then what is the need of the fit? Okay, if we are not considering the fit, then again it will make the effect on the function of the part. It will make the effect on their cost, because if you are not considered fit, so there will be chance of the rejection. Then again it will be directly make effect on your cost also. Okay, for this purpose, to prevent or to remove such rejections, we have to necessary to we have to select the fit first, fit first before the manufacturing. So what are the different types of the fits? Yes.
Clearance fit.
Okay, first is the clearance fit. Okay, then second is the
Interference fit.
okay interference fit, and third is the transition
Transition
fit.
fit.
Simple how to remember this. What is meant by the clearance fit? In that clearance fit we are knowing that, yes,
Shaft size is smaller than hole.
okay, shaft size is smaller than hole. Okay, here in interference,
Shaft size is greater than hole.
okay, greater than the, and here intermediate that. Or again, which definition we have seen here? What is meant by the technical definition for the clearance fit? Okay, if the tolerance zone of hole, yes, if the tolerance zone of the hole is
above the tolerance zone of shaft.
shaft. Okay, and then for the interference tolerance zone of the hole, it should be below the tolerance zone of the shaft. That much point we have covered. So one type of the fit is remaining, that is the transition fit. Okay, that point first upon we will cover here. Okay, so directly I will draw here one figure, and according to that figure we will try to cover that transition fit. Okay, and then we will move toward the next point. Okay, so I will draw here the one figure. Just a bit for this, I will draw. Suppose this is the shaft. Okay, so this is the shaft and this is the hole. So this is the shaft. Okay. Okay, now tell me the tolerance zone for the shaft and hole. Whether see this is the tolerance zone for, yes, yes, please. This is the tolerance zone for hole or shaft.
Hole.
So this is the tolerance zone for the hole, and now see here, this is the tolerance zone for the shaft. Okay, this is the tolerance zone for the shaft. This is the tolerance zone for the shaft. Then prepare the definition for that fit. It is called as the transition fit. Okay, then what is the definition according to the tolerance zone? Okay, yes, anybody? Now see here, in that transition fit, we can call here. Here, the tolerance zone of hole and shaft overlap to each other. Yeah, right? Here, now see, this is the tolerance zone for the hole, and this is the tolerance zone for the shaft. Both are overlapping to each other. Okay, when the tolerance zone of shaft and the tolerance zone of hole are overlap are overlap to each other, are overlap to each other, then we can call it as the transition fit. So this condition is called as the transition fit. Means in that transition fit, okay, the tolerance zone of shaft and hole they are overlapping to each other. म्हणजे बघा हा जर तुमचा होलचा टॉलरन्स झोन असेल आणि हा शाफ्टचा असेल, हे असा ओव्हरलॅप होणार आहे, एक इथं कुठे असणार आहे. Okay, okay, if such conditions are there, then we can call it as the transition fit. So understood? Yes.
Yes, sir.
Okay, so now see here, simple. Okay, first is the clearance fit. In that clearance fit, then tell me the tolerance. Okay, so I will erase that point and then I will write down all the definition here, because if you are understood this fit, then and then only it will be helpful for understanding that next concept. So that I will give more time for this. Okay, clearance fit. Okay, clearance fit. What is the definition for the clearance fit? Yes, the tolerance zone of
Hole
tolerance zone of hole is
above the tolerance zone of shaft.
above the tolerance zone of
Shaft.
shaft. Then how to represent it graphically? Now see, suppose this is the tolerance. Suppose this is the tolerance zone for the hole, and suppose this is the basic line, and suppose this is the tolerance zone for the shaft. So then it is called as the clearance fit. Okay. Then next interference fit. Again, just you have to revise, or we can say the reverse karayala. Okay, interference fit. Okay, in that interference fit, how we can write the definition here? The tolerance zone of hole is below the tolerance zone of
Shaft.
tolerance zone of shaft. Then how to represent it? Again, suppose this is the basic size. Okay, so this is the tolerance zone for the shaft, and this is the tolerance zone for the, okay, such condition. And the last is for the transition fit. Okay, the transition fit means the tolerance zone of shaft and they are overlap to each other. Then how to represent it like this? Okay, how to represent it? Yes, please, how to represent it? हे कसं आपण दर्शवू शकतो? Like this. Just like this. Suppose this is the tolerance zone for the hole or shaft, and in between that there will be the tolerance zone for the shaft, like this. It is correct. It is for the transition. Okay, understood? Or like this, like this. Okay, see, this is the hole. Okay, this is the hole. Okay, this is the hole, and this is the tolerance zone for the shaft. It will be like this. Sometimes it will be like this, or sometimes it will be like this. Okay, they are overlapping. Anyway, they will overlap. Okay, then it is called as the transition. So understood? Yes. Yes. It is understood all.
Yes, sir.
Yes, sir.
Okay, or in simple way also you have to remember, in the clearance fit, the hole is big, shaft is small. Interference fit, hole is small, shaft is small. And transition fit, both are equally, maybe somewhat equal, you can say. Okay, for the better understanding you have to remember likewise. Okay, so understood the concept of the fit? Yes. Again, you have to
Yes,
remember
sir.
that clearance fit is nothing but it is the loose fit. That interference fit, it will be the tight fit. Okay, and the transition fit, it will be sometime it will show in the clearance fit or sometime it will show in the interference fit also. Okay, then okay, so that shaft fit is over. Right now, we are moving toward the next important concept is the whole basis system and the shaft basis system. Again, it is very important point is here. Okay, whole basis system and the shaft basis system. Okay. See. So the next very important topic is whole base system. Whole basis system and shaft basis system and shaft basis system. Whole base system and shaft base system. Okay, so anybody having any idea about this? When we can call it is the whole base system and when we can call it is the shaft base system? So please tell me if you are knowing then. Yes. Route. Yes, anybody?
No, sir.
Yes, from girl side. When we can call it is the whole base system and when we can call it is the shaft base system. Yes. So one by one we will take here and then we will differentiate it. Okay, so first up on I will take here whole base system. Whole basis system. Okay, whole basis system. This is very important topic. Okay, whole base system. Now see what is meant by the whole base system. Simple. Okay, just I will take here one example. Suppose we have to manufacture one hole. Okay, suppose I have manufactured one hole of 15 mm diameter. Okay, suppose I have to manufacture or I have to produce a hole whose diameter it will be 15 mm. Okay, suppose right now I have prepared here a hole like this. Suppose this is the hole I have prepared. Okay. So this hole. Okay. This hole okay, prepared. What is its diameter? What is the diameter for this hole? So this is called as the hole. So this is the hole. And tell me the diameter of that hole is? Yes. What is the diameter?
50 mm.
50 mm. Hole is there. And okay, you have to concentrate here. Okay, we have to follow this system, whole base system. Okay, whole base system. आता बघा या whole base system मध्ये मी एक hole इथे manufacturing केलेला आहे and the size of that hole it will be the 50 mm. Okay, बरोबर आहे. आता काय करायचं असतं आपल्याला whole base system मध्ये in this system, okay, in this whole base system we have to fix the size of hole. Okay, we have to fix the size of hole. We have to fix the size of hole and vary the size of shaft to achieve the various fits. Okay, this is the one point. Fix the size of hole and the second point it will be the vary. Okay, vary the size of shaft to achieve the different fits. What are the different fits? To vary the size of shaft for achieving the various fit means to achieve the clearance fit, to achieve the interference fit, to achieve the transition fit. Okay, we have to just vary the size of shaft. म्हणजे जर आपली होल बेस सिस्टम असेल तर ह्याच्यामध्ये आपण होलची जी काही साईज आहे ते एकदाच आपण फिक्स करून घ्यायची आहे. होलची साईज काय करायची आहे? ओके, जस्ट वी हॅव टू फिक्स द साईज ऑफ होल. Okay, once we have to fix the size of hole, then we should not allow to vary the size of hole. Okay, means first of all we have to produce one hole at the standard size, and to achieve the different phase means to achieve the clearance fit, to achieve the transition fit, to achieve the interference fit. Okay, we have to vary the size of shaft only. Okay, this system is called as the hole base system. Understood? In that hole base system, we have to fix the size of hole only. म्हणजे होल आपण फिक्स साईजचं ड्रिल करून घ्यायचं आहे. ओके, त्यानंतर होल आपण व्हॅरी करायचं आहे का? येस येस
No.
नो. ओके, टू अचीव द दिस फिट्स, टू अचीव द डिफरन्स फिट which we have to vary shaft or hole?
Shaft.
ओके, ओनली शाफ्ट वी हॅव टू व्हॅरी. ओके, मग तो शाफ्ट छोटा करायचा आहे मोठा करायचा आहे तुमच्यावर अकॉर्डिंग टू देअर फिट्स. which fit we have required, according to that just we have to vary the shaft size. Okay, and here in hole basis system the size of hole should not be varied. We have to fix the size of hole. Okay, this system is called as the hole base system. Okay, understood? Yes,
Yes, sir.
but you see here the one more important point is related to that hole basis system is, first point is the we have to fix the size of hole, and second is the vary the size of, yes, vary
Shaft.
the size of shaft. So this is the second point, important point is there. Then third important point is related to that system is hole basis system is, in the hole basis system, okay, in the hole basis system the lower deviation should be 0. The lower deviation is equal to 0. Okay, that point you have to remember. It is very important. म्हणजे काय असेल त्याचा अर्थ? Yes, what is meaning of this? Lower deviation should be 0 means what? Yes, means what? Okay, same, this is the hole. Okay, that hole we have to produce here, and the size of that hole it will be the 50. If we are knowing that to produce the exact size, okay, to produce the exact size, it is possible? No, it is not possible. So that suppose by mistakenly the size of that hole it is going to increase. काय झालं, मॅन्युफॅक्चरिंगच्या एररमुळे त्या होलची साईज थोडी वाढलेली आहे, लाईक दिस. म्हणजे 50च्या ऐवजी होल कितीचं ड्रिल झालेलं आहे आपल्याकडून? 51चं. Again it is allowed. Okay, again it is allowed. But if suppose okay, if in this hole basis system, if suppose, okay, if you have produced the hole, if you have produced the hole of 49.9, like this. If you have produced the hole, okay, by mistakenly suppose you have produced the hole of 49.99, again it will be rejected. It is not called as the hole base system. Means your lower deviation should be 0. म्हणजे काय करायचं आपल्याला, जर मी हे होल ड्रिल केलं, त्या ड्रिलची बेसिक साईज आपल्याला किती दिलेली आहे? 50 दिलेली आहे. ओके, जर 50 पेक्षा वरती आपण टॉलरन्स दिला, 51 केला, 52 केला, इट इज अलाउएबल. बट ह्या 50 पेक्षा जर खाली आलं, 49.99 जर तुमचा होल आला, it will not a hole base system. This is the point. Your lower deviation should be 0. म्हणजे या 50च्या खाली याला अलाउड आहे का तुम्हाला? लोअर डेविएशन शुड बी 0. म्हणजे काय बघा, दिस इज द 0 लाईन. ओके, असं जर टॉलरन्स घेऊन आला असेल, इथं काय असणार आहे तुमचं? येस, इट विल बी द 50. बरोबर आहे का? बरोबर आहे का?
Yes, sir.
ओके, एका ठिकाणी किती येईल? 51 येईल. जर असा खाली ह्याच्या खाली यायला आपल्याला अलाउड आहे का? ह्याच्या खाली यायला अलाउड नाही. म्हणजे काय झालं तुमचं अप्पर डेव्हिएशन झालं. आणि लोअर डेव्हिएशन या ठिकाणी किती आहे माझं? किती आहे लोअर डेव्हिएशन?
0.
0 असणार. सी दिस इज कॉल्ड ॲज द होल बेस सिस्टम. ओके, मीन्स होल बेस सिस्टम मध्ये आपण काय करू शकतो? अप्पर लिमिट देऊ शकतो. सिंपल मध्ये आपलं सिंपल लँग्वेज सांगायचं म्हणलं तर आपण अप्पर लिमिट देऊ शकतो त्या बेसिक साईजला, पण लोअर लिमिट देऊ शकत नाही. या बेसिक साईजच्या खाली जर आलं तर इट इज नॉट कॉल्ड ॲज द होल बेस सिस्टम. ओके, अंडरस्टूड? येस,
Yes, sir.
it is understood or not?
Yes,
Yes, sir.
Yes,
Then-
sir.
Yes, sir.
okay, so then tell me, I
Yes,
will
sir.
take another example here. Suppose I have produced one hole here. Suppose this is the hole I have produced here, and the diameter of that hole, it will be like this. Suppose the diameter of that hole, it will be the 60. Okay, and suppose, so this is the diameter of that hole is the 60, and you have produced a hole of 59.99, and you are following the whole base system. Okay, it is allowable, it is whole base system.
No, sir.
Sir.
Okay, and if suppose you have produced the whole of 60.01, it is allowable,
Yes,
Allowed.
sir.
Yes, sir.
it is the whole base system. म्हणजे कुठले पॉइंट तुम्हाला महत्वाचे आहेत समजायला पाहिजे होल बेस सिस्टम मध्ये? इन दॅट होल बेस सिस्टम, okay, first आपण we have to fix the size of hole in only upper deviation or in upper side only. म्हणजे आपण काय करू शकतो? त्या होलची साईज अप्पर साइडला व्हॅरी करू शकतो. ओके, अप्पर साइडला फिक्स तुम्ही काय टॉलरन्स द्यायचं असेल त्या अप्पर साइडला देऊन घ्या आणि साईज फिक्स करून घ्या. देन त्यानंतर काय करायचं? इन होल बेसिस सिस्टम युअर लोअर डेव्हिएशन शुड बी येस
0.
0.
and to achieve the various fit we can vary the size of shaft.
Shaft.
Now see, that point you have to remember. The first point is in hole base system, the size of hole, okay, we have to fix. Size of hole we have to fix. Then second point का असेल? Yes.
Size of shaft is
Shaft.
Where is the size
Shaft
of
will be variable.
Okay, to achieve the various fit, we have to vary the size of shaft hole.
Shaft.
Vary the size of shaft. And the very important point is in the whole base system, yes, in
lower
the,
deviation?
Lower derivation must be 0.
okay,
should
good.
be
Okay, the lower deviation, it is very important point. It is very important point. The lower deviation of hole or shaft, the lower deviation of hole should be
Whole.
it should
0.
be
0.
0. It is important point. It should be 0. म्हणजे बेसिक साईजच्या खालती आला तर इट इज नॉट अ होल बेस सिस्टम. बेसिक साईजच्या वरती गेला अगेन वी कॅन ऍक्सेप्ट इट, नो प्रॉब्लेम. ओके, सो अंडरस्टूड, दिस इज कॉल्ड ॲज द होल बेस सिस्टम. सो अंडरस्टूड?
Yes, sir.
Then we will take here one example, or I will draw here one figure so that you will understand better. Okay, so understood? Whole base system. In that whole base system, we have to fix the size of hole. Then we have to vary the size of shaft to achieve the various fit. And important point is the lower deviation of hole, it should be minimum. It should be 0. Okay. Now see here, suppose I'm going to draw here one hole because we are showing here the whole base system. Whole base. Okay, so that I will draw here one hole. Suppose this is the hole. Okay. Suppose this is the hole. Okay. So this is the hole. This is the hole. What is this? Yes. Take example. Suppose the diameter of that hole or the basic size. The basic size of that hole, it will be the 50. It will be the 50. This is the basic size. Okay. Basic size, it will be the 50 after this. Okay. And we are knowing whether we can give the upper deviation or we have to give the lower deviation here.
Upper
हे
deviation.
upper
Deviation. म्हणजे जर आपला शाफ्ट 51 चा जर बनला, इट इज अलाउएबल. बरोबर आहे का? बरोबर आहे का? म्हणजे आपण या ठिकाणी
Yes, sir.
डेविएशन कुठलं देणार आहे होल बेसिस सिस्टम मध्ये? मला सांगा. वी हॅव टू गिव्ह द डेविएशन टू द अप्पर साइड ओनली. इट इज करेक्ट?
yes,
ओके. सो दिस इज कॉल्ड ॲज द अप्पर डेविएशन. म्हणजे हे काय असेल तुमचं आता? हे काय झालं? बेसिक साईज झाली ना. 50 इज नथिंग बट आवर बेसिक साईज. 50 पर्यंत आलं तर वेल अँड गुडच आहे. 50 च्या खालती आलं तर हे होल बी सिस्टम होऊ शकतं का? जर हे
नाही.
का होऊ शकत नाही तर आपल्याला त्यांनी कंडिशन काय दिलेली आहे? द लोअर डेविएशन शुड बी 0. ओके. यू कॅन हेर द अपर डेविएशन. सो दिस इज द अपर डेविएशन. ओके. बरोबर आहे का? हे काय असेल तुमचं? हे काय असेल? अपर डेविएशन. लोअर डेविएशन म्हणजेच काय? ते 0 असणार आहे ना, काहीच नसणार आहे इथे. ओके. Okay, now see here, this is the hole. This is okay. We have fixed the hole. Then tell me, suppose we have to achieve the various speeds in that hole basis system. Hole ची size fix करून घेतली का ह्या ठिकाणी आपण? हे किती असेल? प्लस 0.1 0.2 असेल. म्हणजे ह्याच्यावरती काय तर प्लस 1 2 3 आपण देऊ शकतो काय असेल. म्हणजे आपण आता होलची साईज फिक्स केली ह्या ठिकाणी. यस. वी हॅव फिक्स द साइज ऑफ होल. येस ऑर नो?
Yes, sir.
yes, sir.
And right now we have to achieve the various speed. Suppose we have to identify the or we have to produce the clearance speed, interference speed or transition speed. Then how to produce it? Now see here. Okay, you have to remember this is the hole. And how to produce the clearance speed? Yes. How to produce the clearance speed? Okay, to produce the clearance speed, the size of shaft should be less. Shaft आपण काय करू शकतो? छोटा आपण बनवू शकतो. Okay, suppose this is the shaft. Okay, suppose this will be the shaft. So this is the shaft. Okay, this is the shaft. So this is the shaft and this is the hole. Okay, in between this, suppose this is the tolerance zone for the shaft. Okay, this is the tolerance zone for the shaft and this is the tolerance zone for the hole. Then tell me what is this? Which fit is there in between this? Condition number 1. Which fit is there? हे तुमचं होल आहे पूर्णपणे. हा शाफ्ट आहे. शाफ्टची साईज छोटी आहे, होलची साईज मोठी आहे. Okay, this is the tolerance zone for the hole. This is the tolerance zone for the shaft. Then tell me which clearance fit is there? Sorry, which fit is there?
Clearance fit.
It is called as the clearance fit. Okay. Then how to achieve the interference fit? If we have to achieve the interference fit, again we have to manufacture the big shaft because we are having the fixed size of hole. Okay, because we are having the fixed size of the hole, and suppose we have to achieve the interference fit, in that condition we have to manufacture the shaft with big size like this. Okay, that much size shaft we have to require to like this. So this is the tolerance for the shaft. So this is our shaft. So this is the shaft. Now see here. This is the tolerance zone for the shaft and this is the tolerance zone for the hole. And which type of the fit is there? Which type of the fit is here?
Interference.
Yes, it is the interference fit. And to achieve the transition fit, okay, we have to manufacture the shaft whose, yes, whose tolerance zone, it should be lies in between the tolerance zones of this hole. Okay, like this. Like this. So this is the shaft is here. So the tolerance for the shaft. This is the clearance fit. This is the, yes, interference fit, and this is the transition fit.
Transition.
Okay, you from this figure you can easily understood here. We have here we have varied the size of hole. We have varied the size of hole here. We are not varying, na?
No.
We have not varied the size of hole. We are not varied the size of hole to achieve the different fit. Just we have to change the size of shaft only. म्हणजे आपण फक्त shaftची साइज कमी जास्त करत गेलो. जर मला क्लिअरन्स फिट असेल, म्हणजे एकदा होल आपण इथे फिक्स करून घेतला. ओके, एकदा होलची साइज आपण फिक्स करून घेतली तर नंतर आपण काय करायचं आहे, टू अचीव द डिफरंट फिट्स वी हॅव टू जस्ट व्हॅरी द साइज ऑफ शाफ्ट ओनली. शाफ्टच्या साइज आपण चेंज करत जायचं. शाफ्ट छोटा बनवा, मोठा बनवा, इंटरमिडिएट बनवा, and according to that we have to achieve the different. This system is called as the hole basis system. Okay, understood? Yes, this
Yes,
is called as the
Yes, sir.
hole basis system. Clear? Clear to all? Yes.
Yes, sir.
Only that 3 point is important point, or out of that 3 also both are very simple. First is fix the size of hole. Then second, vary the size of
shaft.
shaft to achieve the different fit. And the important point is in that hole basis system, yes, which is important point?
Lower
Lower
deviation.
Lower deviation should be 0.
The lower deviation should be 0. म्हणजे ह्या बेसिक साईजच्या खाली यायला आपल्याला परवानगी का? बेसिक साईजच्या खाली यायला आपल्याला परवानगी आहे का? ह्याच्यापेक्षा आपण छोटा होल बनवू शकतो का? 50 पेक्षा छोटा होल बनवू शकतो ह्याच्यामध्ये आपण?
नाही.
नाही.
It is not allowable. If we have vary that lower deviation, then it is not a hole basis system. It is not hole basis system. Okay, so that 3 points it will cover the hole basis system. Means in that hole basis system we have to fix the size of hole. Then to achieve the different fit, we have to vary the size of shaft. And very important point is in that hole basis system, your lower deviation should be 0. Okay, means we are giving the tolerance in only upper side, not in below side. If you are giving the tolerance in below side, it will be not hole basis system. Okay, understood? Yes. So we will take next is okay. So how to represent that whole basis system in graphical manner? Yes, anybody? How to represent that whole basis system? Whole basis system in graphically. Okay. So I will try here. Suppose this will be the 0 line. Okay. Suppose this will be the 0 line. Okay. Yes, anybody? How to show it is in graphically manner? Yes.
Above the line.
Yes. How to show it in graphically manner? Yes, anybody? How to show? Then tell me. Okay, see here. See, this is the 0 line, huh? Okay, just a minute. So this is the zero line. That line is indicate the zero line. It is correct. So this is the zero line. This is the zero line. Okay, zero line is here. Okay, and we are showing that whole basis system. Means suppose first upon we have to show the tolerance zone for the hole. Or the tolerance zone for the hole, it should be like this. बरोबर आहे का? असंच असणार ना होलचा टॉलरन्स. Okay, so this is the tolerance zone for the hole only. So this is the tolerance zone for the hole. So this is the zero line, means it is indicate the basic size. What is the basic size? Example 50. Okay, 50 च्या वरती आपण जाऊ शकतो ना, होल बेसिस सिस्टम मध्ये जाऊ शकतो का आपण? 50 च्या वरती जाऊ शकतोय का?
Yes.
जाऊ शकतो. म्हणून मी इथे असा टॉलरन्स झोन दाखवला. पण 50 च्या खाली येऊ शकतोय का आपण?
नाही.
नाही.
No.
म्हणजे खाली दाखवायची काय गरज आहे का नाही? So this is the tolerance zone for the कोणाचा आहे टॉलरन्स झोन हा?
होल.
This is the tolerance zone for the hole. Okay, this is fixed. We have fixed it. Okay, right now suppose we have to show the clearance fit. Okay, we have to show the clearance fit. Then see, this is the tolerance zone for the shaft. Okay, so this is the tolerance zone for the shaft. आता shaftचा tolerance zone कसा येणार आहे? खालतीच येणार आहे ना ह्याच्या. बरोबर आहे का?
Yes.
शाफ्टचा टॉलरन्स झोन खालतीच येणार आहे ना, बरोबर आहे का नाही? म्हणजे बघा हे डायग्राम बघा तुम्ही. This is the hole. This is their upper limit tolerance zone of the hole, and here your shaft will be there. This is the shaft, and this is the tolerance zone for the here. Up to this, what is this? This is the basic size. What is this? 50. बरोबर आहे का? This is the tolerance zone for the hole. Now see, this is the tolerance zone for the hole we have drawn here, and this is the tolerance zone for the shaft. That tolerance zone of the shaft is below to the zero line च्या खालीच असणार आहे ना, बरोबर आहे का? Yes or no? See, this is called as the clearance fit. This is called as the clearance fit. आणि इंटरफरन्स फिट कसा असेल आता इथं? इंटरफरन्स फिट मध्ये कसं राहील? हाय टॉलरन्स झोन ऑफ द होल, आणि ह्या टॉलरन्स झोनच्या होलच्या टॉलरन्स झोन पेक्षा तुमचा शाफ्टचा टॉलरन्स झोन कसा पाहिजे? मोठा पाहिजे, वरती पाहिजे, तरच तर आपलं इंटरफरन्स होणार आहे. दिस इज द टॉलरन्स झोन फॉर द शाफ्ट, and this is called as the interference fit. This is called as the clearance fit. Okay, and transition fit ला कुठं पाहिजे? The tolerance zone of the shaft should be like between here, or here. This is called as the transition. So understood?
सर ते क्लिअरन्स फिटला अबव आहे ना टॉलरन्स झोन
कुणाचा?
शाफ्टचा.
काय डेफिनेशन आहे मला सांगा क्लिअरन्स फिटचे?
Tolerance zone of hole is about the tolerance zone of shaft.
टॉलरन्स झोन ऑफ होल इज अबव, बरोबर आहे का? टॉलरन्स झोन ऑफ द होल इज अबव, आणि टॉलरन्स झोन ऑफ शाफ्ट इज बिलो. करेक्ट?
हा.
बघा बरं काय? दिस इज द टॉलरन्स झोन फॉर द शाफ्ट. This is the tolerance zone for the shaft, and this is the tolerance zone of the hole. म्हणजे अबव का खाली कसं आहे? होलचा टॉलरन्स आपण वरती दाखवला नाही बेसिक लाईनच्या, आणि खालती दाखवलेला आहे.
हा.
then it is clearance fit. आणि इंटरफरन्सची डेफिनेशन काय सांगते आपल्याला? टॉलरन्स झोन ऑफ द होल. यस,
Below the tolerance zone of shaft.
बिलो ही कोणाची झाली टॉलरन्स झोन? होलची झाली, आणि शाफ्टची झाली, इंटरफरन्स झाला. आणि हे ज्या मिडल असेल तर इट इज द ट्रान्झिशन फिट. सो अंडरस्टूड? इट इज कॉल्ड ॲज द होल बेस सिस्टम. म्हणजे आपण ह्याच्यामध्ये आपण काय करून घेतलं? सुरुवातीला होलची साईज ही काय फिक्स करून घेतली, आणि त्यानंतर शाफ्टची साईज वाढवली. इट इज कॉल्ड ॲज द होल बेसिस सिस्टम. सो अंडरस्टूड?
Yes, sir.
So the next point is shaft basis system. And what is meant by the shaft basis system? Yes, कसं असेल आता? shaft basis system.
Constant.
Shaft basis system. Shaft basis system. Okay. Again, what are the important points related to that? Okay, just take here first. In that shaft basis system, we are fix the size of shaft. Where fix the size of shaft. Okay. Where fix the size of shaft. And yes, to achieve the various speed, we are vary the size of, yes,
Hole.
vary
Hole.
the size of hole. Vary the size of hole. Okay. These are the reverse only. आता आपण होल मध्ये काय करत होतो, होल फिक्स ठेवत होतो आणि शाफ्ट व्हॅरी करत होतो. शाफ्ट बेसिस सिस्टम मध्ये आपण आता काय करणार आहे, इन दी शाफ्ट बेसिस सिस्टम वी आर फिक्सिंग द साइज ऑफ शाफ्ट. शाफ्ट फिक्स करणार आहे कॉन्स्टंटला आणि होल व्हॅरी करायला लागणार आहे. ओके. And the important point is, yes, काय असेल important point here?
Upper deviation should be 0.
Deviation should be 0.
It is the upper deviation should be
0.
it is very important. Should be 0. Should be 0. म्हणजे काय? Suppose example we have to manufacture the shaft is equal to 50 mm diameter. मला काय करायचं, 50 mm diameter shaft manufacture करायचा आणि कुठली सिस्टम फॉलो करायची मला, we have to just follow the shaft basis system. Okay, suppose we have just okay, suppose this is the shaft. So this is the shaft. So this is the shaft. Okay. And what is its basic size? What is the basic size? It is the 15 mm चा एक मला shaft manufacture करायचा. Okay, but we are knowing that it is not possible to produce the exact 15 mm. म्हणून काय केलं, जर आपण काय केला, हा 51 चा 51 mm चा 51 mm चा shaft बनला आपल्याला. Okay, 50 mm चा like this. Okay, असं shaft बनला आपल्याला. Okay, then tell me whether it is called as the shaft basis system. Yes, whether it is called a shaft basis system.
No.
No.
Why?
Upper deviation is more than 50.
It is the 50. It is not called as the shaft basis system. What is the condition for the shaft basis system? Your upper deviation should be 0. Upper deviation should be 0. म्हणजे आपल्याला 50 च्या वरती जाण्याची परवानगी दिली आहे का त्याने?
No.
No. Okay, जर तुम्ही समजा, suppose we have manufactured the shaft of 49.99. Whether it is shaft basis system?
Yes.
If we have manufactured the shaft like this, okay, again it is accepted. It is called as the shaft basis system. म्हणजे काय करायचं आपल्याला, सिंपल डिफरन्स आला का लक्षात तुमच्या, होल आणि शाफ्ट. होल मध्ये काय करायचं आहे, जर तुमचा होल मोठा झाला, बेसिक साईज पेक्षा जर मोठा झाला तर ते अलाउएबल आहे, आणि शाफ्ट बेसिस सिस्टम मध्ये काय करायचं, तुमचा शाफ्ट बेसिक साईज पेक्षा जर छोटा झाला, इट इज एक्सेप्टेबल. Yes, understood?
Yes, sir.
Okay.
Yes.
So this is called as the shaft basis system. म्हणजे in that shaft basis system where fix the size of shaft, then we will vary the size of hole to achieve the various speed. And in the shaft basis system, your upper deviation should be 0, and in that hole basis system, your lower deviation should be 0. That 2 point you have to do. So understood?
Yes, sir.
Okay. Then tell me. Okay, just I will draw here one figure so that you will understand better. Okay, whole basis system. Suppose I will draw here one shaft. Okay, suppose this is the one shaft is here. Suppose this is the shaft, and for example, the basic size of that shaft is should be 50. Okay, it should be the 50. And we have to give the deviation. And which deviation we should give here? Which deviation? Which deviation we can provide to the shaft, whether upper or lower? Which deviation we will allow
Lower.
here? Means like this. म्हणजे आपण काय करू शकतो, जर आपला शाफ्ट कमी जर मॅन्युफॅक्चरिंग झालाय 1 mm 2 mm तुमच्या टॉलरन्स नुसार, इट इज एक्सेप्टेबल. इट इज कॉल्ड एज द this is okay. Okay, this is the tolerance zone for the shaft. This is the tolerance. This is the basic size. Huh? So this is the basic size. This is the basic size. See, this is called as the basic size, and this is your lower deviation. Okay, and this is the tolerance zone. Okay, now we have fixed the shaft here. आता आपण shaft ची size fix केली का इथं? Yes.
Yes.
For example, it will be the 49.99 एवढा अलाउएबल आहे आपल्याला, टॉलरन्स दिलाय त्याने. ओके, तर आपण ही साइज फिक्स करून घेतली एकदा. Yes, it is called as the shaft basic system. Means here we have fixed the size of shaft. Yes, understood? Yes. So it is called as the shaft. And right now we have to achieve the different fits. Then how to achieve the different fit? First phase fit we have to achieve here clearance fit. Then how to achieve the clearance fit? Yes. Clearance fit आता काय करावं लागेल आपल्याला? In that clearance fit, hole is larger and shaft is smaller. म्हणजे तुमचा होल आता कुठे येईल? इथे घ्यायचा का होल आपण?
Above.
Okay. The tolerance zone of hole should be above the tolerance zone of the shaft. बरोबर आहे की नाही? Yes or no?
Yes.
म्हणजे असं असेल का? समजा suppose this is the hole is here. This is the hole and this is the tolerance zone for the hole. Whether it is clearance fit. See, this is the tolerance zone for the shaft and this is the tolerance zone for the hole. There is a gap, means it is the clearance fit. Yes.
Yes, sir.
It is the clearance fit. Then next fit, it is the interference fit. Then how to show the interference fit? Interference fit मध्ये कसं काय? Shaft size should be greater and hole should be smaller, no? Yes. See, this is the shaft size already we have fixed here. Okay, we cannot vary this shaft size. Then we have to produce the small hole here like this. Suppose this hole we have produced here like this. See, this is the hole and this is the tolerance zone for the hole. This is the tolerance zone for the hole. See, this is the tolerance zone for the hole and so this is the tolerance zone for the shaft. Then which fit is there? It is the interference fit. And now see here we have produced the hole like this. So this is the tolerance zone for the hole and this is the shaft. Then what is this fit? Yes.
Transition.
It is the transition. It is the transition. Okay. Here you can observe whether once we have to fix the size of that shaft, then we have vary the size of shaft here. म्हणजे एकदा जर आपण shaft ची size fix करून घेतली तर नंतर मी vary केली की shaft ची size
नाही.
Just to achieve the difference fit, I have vary the size of only
Hole.
म्हणजे फक्त मी काय केलं या ठिकाणी होलची साईज व्हॅरी करत गेलो. ओके, होलची साईज व्हॅरी करत गेलो म्हणजे शाफ्ट साईज मध्ये काय करायचं आपल्याला शाफ्ट बेसिस सिस्टम मध्ये एकदाच आपण शाफ्टची साईज फिक्स करून घ्यायची तो कॉन्स्टंट ठेवायचा. परत त्याची साईज आपण व्हॅरी करायची का नाही. त्यानंतर आपल्याला काय करायचं आहे according to our fit requirement, we have to change the size of hole only. Okay, if you have produced the hole small, it will become the interference. If you have produced the hole big, it will become the transition. In between that, it will be in between the transition, clearance, interference, like this. Okay, such type of the fit will be produced. Okay, so understood? Yes or no?
Yes, sir.
Okay, so we will write down here the difference between the shaft based system and hole based system. So you have to tell me the difference here. Okay. Okay, in this set I will write here the hole based system. Okay, before that, anybody can tell me how to show that shaft based system in graphical manner? Yes, how to show the shaft based system in graphical manner? Yes. Shaft based system. How to show it graphically? Suppose this is the zero line. Okay, see this is the zero line. We can see this is the basic line. Okay, then tell me here in shaft based system, which tolerance zone we are fixing? We are fixing the tolerance zone of this tolerance zone of the shaft only. आता मला सांगा टॉलरन्स झोन ह्या बेसिक लाईनच्या खाली येणार का वरती जाणार आता?
खाली.
का? why it is showing at below side?
अप्पर
अप्पर
डेविएशन
डेविएशन 0 आहे म्हणून.
ओके, अप्पर डेविएशन आपलं काय असणार आहे? 0 असणार आहे. लोअर डेविएशन तुम्ही देऊ शकता. म्हणून हे काय केलं, दिस इज द टॉलरन्स झोन फॉर द शाफ्ट. म्हणजे हा टॉलरन्स झोन आपण फिक्स करून ठेवला. दिस इज द टॉलरन्स झोन फॉर द शाफ्ट. ओके, म्हणजे हा फिक्स आहे. आता आपण व्हेरी करणार का हे?
नाही.
ओके, नाउ वी हॅव टू अचीव द डिफरंट फिट्स. मला आता काय करायचं? क्लिअरन्स फिट अचीव करायचं. देन टेल मी हिअर वी शुड शो दॅट टॉलरन्स झोन फॉर द होल. हे काय आहे? टॉलरन्स झोन कशाचा आहे? शाफ्टचा आहे.
अप्पर द 0 line.
Here we have to show. Can we show here?
Yes.
It is the tolerance zone for the hole. It is the tolerance zone for the, whether it is clearance fit. Yes.
Yes.
It is the clearance fit. And how to show the interference fit? Here we should. म्हणजे क्लिअरन्स फिट मध्ये काय राहतं? होल मोठा राहतो आणि शाफ्ट छोटा राहतो. आता इंटरफरन्स फिट मध्ये काय असणार आहे? इंटरफरन्स फिट मध्ये काय असणार आहे?
होल लहान शाफ्ट मोठा. शाफ्ट मोठा असणार आहे होल पेक्षा.
शाफ्ट
मोठा असणार आहे.
शाफ्ट काय असणार आहे? हा, येस येस प्लीज. हा, येस येस येस.
शाफ्ट मोठा असणार आहे. सॉरी. हा, येस. आणि होल बारीक असणार.
होल काय असणार आहे? लहान असणार आहे. करेक्ट? इट इज करेक्ट or wrong?
Yes, sir.
Yes, sir.
Okay, then here we have to show the tolerance zone for the shaft, sorry, hole, to achieve the interference fit. कुठे दाखवायला लागेल आपल्याला टॉलरन्स झोन?
Below basic line.
म्हणजे इथे कुठे दाखवायला लागेल असं? This is the tolerance zone for the hole. बरोबर आहे का?
Yes.
म्हणजे बरोबर आहे का नाही? हे शाफ्ट मोठा झाला नाही, शाफ्ट मोठा झाला की तुमचा. शाफ्ट मोठा झाला आणि होल छोटा झाला, म्हणजे कुठलाही झाला इथे फिट इंटरफरन्स फिट झालं. ट्रान्झिशन फिटला कुठे दाखवायला लागेल आपल्याला? येस, हिअर वी हॅव टू शो द टॉलरन्स झोन ऑफ होल. हिअर इन बिटवीन द टॉलरन्स झोन ऑफ द शाफ्ट इटसेल्फ. बरोबर आहे का? हे झालं इंटरफरन्स फिट. व ह्या ठिकाणी हे झालं इंटरफरन्स फिट. इट इज करेक्ट or wrong?
Correct.
So you have understood the concept why we are showing this?
Yes.
Remaining student,
Yes, sir.
remaining,
Yes, sir.
why we are showing this tolerance zone in this side, why we are showing the tolerance zone in this side? Whether you understood? Yes, because this tolerance zone already we have fixed. So this is the tolerance zone for the shaft. shaft tolerance zone is fixed, and according to that, just we have to vary the tolerance zone of the hole only. We have to achieve the shaft basis system. So understood? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so we will write down here the difference. Okay. So here it is the whole base system in this side. This is the whole base system. Full basis system, and it will be the shaft base system. Shaft basis. Shaft basis system and the full basis system. Then tell me what is the first point in that whole basis system. In the whole basis system, we are fixing the size of
Size of hole.
Hole.
okay. We'll fix the size of hole, and here in the shaft basis system,
Fixing
Is
the
the
size
size
of
of shaft.
here fix the size of shaft. Fix the size of shaft. Okay, then second point here, to achieve the various fit. Okay, to achieve the various fit, fix the size of hole. And second point काय असणार इथं? Vary
the shaft size.
the size of shaft to achieve the fits. Okay, to achieve the fits. And here
Vary the hole
Vary the
size.
size of hole.
Size of hole.
vary the size of hole. Vary the size of hole for achieving the various fit, na?
Yes.
To
Yes, sir.
achieving the fits. To achieve the fits here. Then important is here. In the lower basis system, in the full basis system,
Lower deviation should
Lower
be
deviation should be 0.
the lower deviation is equal to 0. Here,
Upper deviation is
deviation
equal
should
to
be zero.
upper deviation should be 0.
Zero.
Then tell me which system, whether whole basis system or shaft basis system, it is easy to use. Which system is prepared more? Which system it will be prepared
Whole
more?
basis system.
Okay, generally the whole basis system it will be repaired. Okay, why it will be repaired? Yes, what is the
Easy to
reason?
change the shaft size.
Because see here, in the whole basis system, okay, in the whole basis system, we are fixing the size of hole. Okay, we are fixing the size of hole. Okay, once we have to produce the hole, it will become fixed. Then in this whole basis system, we are varying the size of only shaft. We are varying the size of shaft, and to varying the size of shaft, it is very simple. आपण कशी साइजची shaft vary करू शकतो? With the help of the turning or with the help of the grinding. Okay, with the help of the turning and with the help of the grinding, we can easily vary the size of shaft. ना साइजची shaft छोटी करणे सोपं आहे, बरोबर आहे की नाही? To vary the size of shaft, it is very simple with the help of the turning and grinding process. But to vary the size of hole, it is very difficult because we are having the standard bits are there. How we can produce the hole? With the help of the drilling bit. Okay, we are producing the hole here with the help of the drilling bit, and that drilling bit it will be at the standard चे असतात drilling bit. Drill bit जे काय असतात आपल्याकडे standard ची size चे असतात. म्हणजे तुम्हाला एखाद्या वेळेस समजा 10च पाहिजे असेल, 10.5 पाहिजे असेल, 10 पॉइंट काय तर पाहिजे असेल, तर हे साइज मध्ये बसायला पाहिजे, तरच ते होल तुमचं फिक्स व्हॅरी होत जाणार आहे. येते का लक्षात? येस ऑर नो?
Yes, sir.
म्हणजे
Yes, sir.
शाफ्ट होल बेसिस सिस्टम मध्ये आपण शाफ्ट इझिली व्हॅरी करू शकतो, पण आपण शाफ्ट बेसिस सिस्टम मध्ये होल आपण इझिली व्हॅरी करू शकतो का या ठिकाणी? होल आपण व्हॅरी करू शकतो का इझिली? No, it is very difficult because we are producing the hole with the help of the standard bit. Standard चा शब्द लक्षात घ्या तुम्ही, स्टँडर्ड बीट असणार आहे, ड्रिल बीट, त्यानुसारच आपण चेंज करत जाणार आहे. म्हणजे आपल्या अकॉर्डिंग टू द आपल्या रिक्वायरमेंट नुसार आपल्याला होल आपण कधी कुठे घेऊ शकत, लाईक दिस, इन दिस मॅनर. Okay, so generally hole basis system it will be prepared because to vary the size of shaft it is very simple, and in the shaft basis system to vary the size of hole it is difficult. So that generally the hole basis system it will be prepared. Okay, to understood?
Yes.
So any doubt, any problem regarding to this? Yes, please. Okay. The next important point is there, selection of fit. How to identify the fit? Okay, it is very interesting, and one technique is there. Just I will explain here one technique how to identify the fit. Okay, so selection of fit. Selection of fit. Okay, already we are knowing that what is meant by the feet, what are the different types of the feets. Okay, first is the clearance feet, second is the interference feet, and third is the
Clearance.
okay. These are the three types of the feet we are knowing that, and what is meant by the feet also we are knowing. It will show the tightness and looseness between two mating part. It is called as the feet. In the clearance feet, in the clearance feet, in the interference feet, and in the transition feet, what are the position of that hole and size, it also we are knowing. It also we are knowing. Okay, so then how to identify the fit? Suppose in exam they will ask the question like this. Okay, suppose the exam they will ask the question like this, 20 H7 / G6, then and they will ask the question, identify the fit. Identify the fits or tell the types of the fit. Yes, how to identify the types of the fit here? Okay, such type of the question they will ask. Like this also you will ask, or another matter is they will ask like this, 20 H7 - G6. Okay, identify the types of the fit. Or they will ask the question like this here, 20 H7 divided G6, in this manner. Okay, in this three manner they will ask the question. Identify the fit. Then how to identify the fit here? Yes, anybody having any idea? Okay, so
Clearance fit.
okay, just see here. For example, suppose first upon we will see here the meaning of each and every term. Okay, just example. Okay, suppose they have given the fit like this, 20 H7 / G6. Then what is the meaning of that letter? Okay, the first letter or first figure, it will indicate the 20, it will indicate the basic size. Okay, 20, it will indicate the basic size. Here that EH, it will indicate the EH, it will indicate the whole deviation. It will indicate the whole deviation. Okay, then that 7, it will indicate the IT grade for the, it will indicate the IT grade for tolerance. Sorry, it will indicate the IT grade of tolerance for the and your small g letter, it will indicate the shaft deviation. It will indicate the shaft deviation. And your small 6, it will indicate the, yes, IT grade for the, yes,
Tolerance of shaft.
okay, IT grade of tolerance for the shaft. Means here this 20, it will indicate the basic size. That capital letter H, it will be indicate the whole deviation. That small letter, it will indicate the shaft deviation, and that figure it will indicate the IT grade for the shaft, IT grade for the IT grade for the hole, IT grade for the shaft. Okay,
IT grade का है sir.
that's what we will discuss. Okay, you don't concentrate on that what is meant by the IT grade and that. Okay, they will explain. Just follow the procedure. Okay, I will explain all things. Now see here, I will take another example here. You have to tell me. Suppose like this. Okay, 13. Let's say 1/G8. Then tell me what is the meaning of 13?
Basic size.
Basic
Basic
With
size.
the basic size. And what is meant by the EH? What is meant by the
deviation of
EH?
hole.
Hole deviation.
It is
Hole
the hole
deviation.
deviation. Then what is meant by 7?
IT grade of
Tolerance of hole.
Okay, IT grade for the tolerance of the
Hole.
hole. Then G8 is indicate the
Shaft deviation.
deviation.
okay, it will be the shaft deviation, and it indicate the
IT grade of
IT grade of
IT grade
tolerance.
for the
Shaft.
tolerance for the shaft.
shaft.
Just I will explain here the techniques. Then what is the use of that IT grade? Okay, that point we will explain later. Okay, on that also we will take the one numerical. Okay, just here I will explain the techniques how to identify the fit zone. Okay, just I will explain here the techniques. Okay, so see here. Okay, okay, you have to remember the whole sizes. Okay, the whole size it will be indicated by the capital letter. The whole size it will indicate the capital letter. That point you have to remember. Okay, the whole size it is indicated by the capital letter, and the shaft sizes it will be indicated by the smaller letter. Okay, smaller letter. That point you have to remember. Okay, जे काय तुमचे कॅपिटल लेटर असणार आहेत ते काय दर्शवणार आहेत that capital letter it will indicate the full size, and the smaller letter it will indicate the
Shaft
Shaft
size.
size.
shaft size. Okay, right now there are 25 fundamental deviations are there. Okay, 25 fundamental deviations are there. And what is meant by the fundamental deviation? Simple. The fundamental deviation is nothing but the deviation closer to the basic size. Okay, म्हणजे काय? Fundamental deviation is nothing but it is the deviation close to the basic size. Okay, it is the close to the basic size. Basic size. For example, suppose this is the basic size is there, and this is the tolerance. This is the tolerance. This is we can call the upper deviation, and it is the lower deviation. Then tell me which deviation is closer to the this zero line. Which deviation is closer to that zero line?
Lower.
Lower.
Deviation. And it's in this condition. In this condition, which deviation is closer to the zero line? This is the upper deviation, and it is the lower deviation. Okay, in this condition, the deviation which is closer to the zero line, it is called as the fundamental deviation. It is called as the fundamental deviation. That point just have to remember. Okay, so that okay, for the whole basic system and shaft basic system, there are the 25 fundamental deviations. 25 fundamental deviation. आपल्याला किती fundamental deviation आहेत? Yes, म्हणजे आपण 25 पद्धतीचे शाफ्ट तयार करू शकतो, आणि 25 पद्धतीने आपण काय करू शकतो? होल तयार करू शकतो. Okay, and you have to remember that hole it will indicate the capital letter, and that shaft size it will indicate the smaller letter. Okay. That point you have to remember. This is according to the BI system. Okay, BI system. Okay, then this is the very simple technique. Okay, how to identify the fitting. So I will write here. Okay, whole size आपण कशाने दर्शवणार आहे म्हणले इथं? Whole size. whole size is equal to capital letters, capital alphabet letters like this. Okay, whole size means for the whole it having how many divisions are there? Yes,
25.
25 divisions are there. Like here, whole size आपण कसे दर्शवतोय? Capital letter. Just you have to write down all the capital letters. A, okay, B, C, D, E, F, G, H. Okay, this is the one set. Then I will going to write down here I, J, K, L, M. Okay, then O, P, Q, R, S, T, U, P, W, X, Y. How many letters are there? How many letters are there? It will be the 26. Okay, it will be the 26. Okay, आता काय करायचं आपण ह्याच्यामधून? ओके, त्या सिस्टीम मध्ये काहीतरी चेंज झाल्यामुळे आपण काय करतो आता बघा इथं I, L, O, Q and W we have to remove. Okay, we have to remove. म्हणजे कुठले कुठले असले आपल्याला रिमूव्ह करायचे आहेत? I रिमूव्ह करायचं आहे, L रिमूव्ह करायचं आहे, O रिमूव्ह करायचं आहे, Q रिमूव्ह करायचं आहे आणि W. किती रिमूव्ह झाले?
5.
किती राहिले डिव्हिजन आता या ठिकाणी?
21.
21.
ओके, 21. आता काय करायचंय? हे जे काय आपण रिमूव्ह केलेले आहेत त्यांच्या ठिकाणी काय आपल्याला रिप्लेस करून घ्यायचंय बघा. ओके, वी हॅव टू रिप्लेस इट. आयच्या ठिकाणी आपल्याला काय रिप्लेस करायचं आहे? GPS. ओके, and here we have to add ZA, ZB and ZC. म्हणजे किती ऍड केले आपण या ठिकाणी आता? 1, 2, 3, 4. म्हणजे किती झाले पर डेविएशन आपले?
25 झाले.
ओके, आता काय करा? कुठले कुठले एलिमेंट करून टाकायचे आपल्याला? कुठले एलिमेंट करायला लागतील आपल्याला? आयच्या ठिकाणी काय टाकायचं आहे?
JS.
आयच्या ठिकाणी आयच्या ठिकाणी काय येणार आपलं? यस,
J.
जे
JS.
जे एस आणि आपलं इथं पहिलं होतं ते जे. बरोबर आहे का? त्या ठिकाणी आणखी आपल्याला काय रिमूव्ह करायचं? एल रिमूव्ह करायचं. एलच्या ठिकाणी काय येईल?
2A.
ZA.
एलच्या ठिकाणी काय टाकायचं? सॉरी, एल रिमूव्ह करायचं. त्यानंतर ओ रिमूव्ह करायचं, क्यू रिमूव्ह करायचं आहे आपल्याला, आणखी डब्ल्यू रिमूव्ह करायचं. That one to have to remove. Spina. It is Spina.
Yes.
And here we have to add the ZA, ZB, and ZC. Now, how many fundamental divisions are there for the whole? It will be the
25.
okay. I will read that. It will be the 25. So understood? Similar manner, we have to write down the deviation for the shaft also. Okay, shaft. How to show the shaft size here? With the help of the smaller letter. May I write? Yes, A, B,
Yes.
C, D, E, F, G, and H. Then second, it will be the like this. Okay, G, S. Okay, then J, then K, M, E. Okay, then P, yes, P, R, yes,
Yes.
T,
TUV.
U, V, yes, X, Y,
XY
Z,
Z
ZA,
ZA
ZB. How many are there? It will be the
25.
derivation for the shaft. Okay, simple. हे समजलं का सर्वांना? Yes. Okay, now so just you have to remember this. Okay, then see here. Okay, then see here how to identify the pit. Okay, so directly I will take here example and I will explain that techniques here. Okay, for example, they have asked the question like this: identify the pit of following like this: 20 H 7/G6. Okay, as आपल्याला example दिलेला आहे. And they have told us identify the pits. What is by the 20?
Basic size.
Basic
It is the
size.
basic size. It is the deviation for the whole. IT grade for the whole. Then it is the shaft deviation. IT grade for that shaft. Okay. Again, to identify the pits. Okay, in this technique, please remember, in this technique, that 20 basic size is not required us. Again, grade is not required us. Again, this grade is not required us. Means to identify the pit in these techniques, we have to require only that much letter. That H/NG. That much letter is required here in this technique. It is important point. In this technique मध्ये ह्या टेक्निक मध्ये फक्त आपल्याला हे दोन लेटर जर माहित असेल तर आपण फिट आयडेंटिफाय करू शकतो. Okay, then here if such type of such condition is there, okay, if such conditions are there, then how to identify the pit? आता या ठिकाणी काय करायचं बघा तुम्ही, स्लॅशच्या ठिकाणी स्लॅशच्या लेफ्ट साइडला जायचं, स्लॅशच्या राईट साइडला जायचं. झालं लेफ्ट साइड, झालं राईट साइड. तर मला सांगा त्या स्लॅशच्या राईट साइडला कुठलं लेटर आहे? if
G.
if the left side of this slash there is the capital letter between, if there is the capital letter between that A to H, if this slash, this left side of this slash, if there is the capital letter between A to H, then to identify the pit, okay, then to identify the pit we have to move toward the G. म्हणजे आता आपल्याला pit आयडेंटिफाय करण्यासाठी कुणाकडे जावं लागणार आहे? जी कडे जावं लागणार. कधी जर या स्लॅश ह्या रेषेच्या पलीकडचं जर लेटर या ABCD H पर्यंत असेल, ABCD तर H मधलं कुठलंही लेटर जर सुरुवातीला कॅपिटलचं असेल या स्लॅशच्या लेफ्ट साइडला, तर आपल्याला फिट आयडेंटिफाय करण्यासाठी कुठे जावं लागेल? कुठे जावं लागेल? स्लॅशच्या राईट साइडला जावं लागेल. आता राईट साइडचं लेटर कुठलं आहे? व्हॉट इज दिस लेटर?
G.
G. Then we have to identify where is J. Okay, J is lies between in this J, that small J, it is lies between that small A to H. If this in between that one of the letter is there to that A to H, okay, that small letter A to H, it will indicate the clearance bit. It will indicate the clearance bit. Okay, it will indicate the clearance bit. समजलं का? Yes or no?
Yes.
No, sir. नाही sir.
Okay. Just a moment. I will explain once again. Simple. जरा लक्ष द्या, कळून जाईल. एक्झाम्पल काय दिलेलं आहे? फॉर एक्झाम्पल 20 H/G6. ओके, ह्या टेक्निक मध्ये आपल्याला फिट ओळखण्यासाठी ह्या 20 ची काही गरज नाही, 7 ची काही गरज नाही, 6 काही गरज नाही. काय लागते फक्त आपल्याला? कुठले लेटर लागते? H आणि G बघायचं. बरोबर. जर सुरुवातीला जर कॅपिटल लेटर, जर सुरुवातीचं कॅपिटल लेटर जर ह्या ABCDEF H यापैकी जर असेल, सुरुवातीचं कॅपिटल लेटर जर ह्याच्या A to H पैकी जर असेल, तर आपल्याला फिट ओळखण्यासाठी ह्या साईडला जावं लागतं, जी कडे जायचं आहे. का सुरुवातीचं कॅपिटल लेटर कुठलं आहे? H आहे. H कशामध्ये आहे? A to H मध्ये आहे का? इथलं
Yes.
म्हणून फिट ओळखण्यासाठी मला कुठे जावं लागतं, जी कडे जावं लागतं. तर जी कुठे आहे बघायचं, जी जर ह्या तुमच्या स्मॉल ए टू एच ह्याच्यामध्ये जर असेल, ह्याच्यामधलं जर कुठलं लेटर जर ह्या स्लाइडच्या ह्या साईडला असेल तर इट विल बी द क्लिअरन्स फिट. येतं का लक्षात?
हो सर.
Then tell me second example I will write down here. 20 H7 slash F6. Then tell me what is the fit? 20 is
Clearance.
required.
Clearance fit.
Yes. Okay, just I will write here H F. And then how to identify the fit? Here capital letter is the H and that capital letter H is lies between A to H. जर हे कॅपिटल लेटर सुरुवातीचं A to H च्या लिमिट मधलं असलं, या मधून कुठलं जर असलं तर आपल्याला फिट ओळखण्यासाठी कुठे जावं लागतंय, टू आयडेंटिफाय द फिट वी हॅव टू गो टू दिस साइड अँड टू शो और टू चेक this side letter. What is this letter? F. If this small letter is in between this A to H, then it is the clearance fit. Okay, then tell me 30 H7 A. Then tell me what is the fit here? Which fit is here?
Clearance.
Clearance.
Clearance
Why it is
fit.
clearance? Why it is clearance?
Small a असल्यामुळे.
Why it is clearance fit?
Capital letter H is in between A and H.
बरोबर आहे. See here, this capital letter H is lies in between this A to H, so that to check the fit we have to go to the this side. बरोबर आहे का नाही? हे सुरुवातीचं कॅपिटल लेटर जर आपलं A ते H मधलं कुठलं जर असेल तर आपल्याला फिट चेक करण्यासाठी कुठे जावं लागतंय, या साईडला जावं लागतंय. त्यानंतर हे लेटर बघायचं, हे लेटर कशात आहे, हे लेटर A ते H मध्ये आहे म्हणून ते क्लिअरन्स फिट. ओके, दिस इज द सिंपल टेक्निक. अंडरस्टूड?
Yes, sir.
ओके, देन सेकंड बघा आता. This is the first fit. Second fit आपल्याला आयडेंटिफाय कसं करायचं बघा या ठिकाणी. ओके, if such type of the fit they have given like this, if 20 m 7 slash G6, then we have not required this 27 is not required, 6 is not required. That much we have required here only m slash G. Then tell me whether that capital letter is lies between A to H.
No.
Yes.
No.
It is lies in between that A to H. No. If this capital letter is not lies in between that A to H, then it is not necessary to go to identify fit in this direction. जर आपलं कॅपिटल लेटर A ते H मधलं नसेल तर आपल्याला ह्या G कडे जावं लागतंय का त्या फिट तयार करण्यासाठी? नाही लागत. फक्त आपण ह्या कॅपिटल लेटर वरच आयडेंटिफाय करू शकतो कुठले फिट आहे. आता कॅपिटल लेटर M कुठं आहे? जर तुमचं सुरुवातीचं कॅपिटल लेटर G ते N मधलं असेल, G आणि N मधलं असेल तर इट विल इंडिकेट द ट्रान्झिशन फिट. इट विल इंडिकेट द ट्रान्झिशन फिट. ओके, समजतंय का? Yes or no?
Yes, sir.
Okay, so I will take another example. Please tell me if 20 P7 slash H6, then tell me which type of the fit is there. P capital P7 dash small H6. Then tell me what is the fit. What is the fit? Yes. Just check. It is the capital letter P. Whether P is lies between this A to H.
No.
No, means it is not necessary to check in this side. It is necessary to check in this side. No.
No.
It is the capital letter. Here it is capital letter P. That P is lies between that A to ZC. Okay, if any capital letter is there in between that P to ZC, then we can call it is the interference fit. It is the interference fit. Then tell me what is the fit of this type?
Interference fit.
Interference fit. Okay. So I will take another example here. Then tell me if like this 30 P yet and small k 9, capital Phi and small g. Then tell me which type of the fit is there?
Interference fit.
Interference.
How we have identified as interference fit? Remaining student, only two students they are giving the answer. Remaining. Yes, how to identify it? Now check, this is the capital letter. Okay, that capital letter is where it is lies between this. Okay, if this capital letter is not lies in between this A to H, then I have to check this forward. Okay, this side I have to check, and where it is in this condition, so that it is interference. Okay, so understood? Yes or no?
Yes.
Yes, sir.
Okay, so next point is remaining. If they have given like this, if they have given just one minute. If suppose they have given like this 20 EH, capital EH 7/G6, then tell me how it is.
Clearance fit.
Clearance fit.
Yes, what is this?
Clearance fit.
Clearance fit. Okay. It will be the clearance fit. How you identify it is the clearance fit? Because okay, just check H and G. Where is H? H is lying between in this A to H. Sorry, this H is in between A to H, so that to identify the fit, we have to go to this side and we have to identify where that J is here. That G is in between this small A to H, and for the small A to G or small A to H, it will be the clearance fit. Okay. Yes.
Yes.
Yes, sir.
So take here next example. If such condition is there, H7/P6, then tell me P6. Yes. Again see here, it is the capital H. Capital H is lies between A to H. म्हणून काय करायचं मला आता फिट आयडेंट करण्यासाठी कुठे जावं लागेल आपल्याला? इकडे जावं लागेल. पी कुठे आहे बघायचं, स्मॉल पी कुठे आहे ह्याच्यात? स्मॉल पी. Again similar process. That small p to z, that's more p to small p to zc. Again it will indicate the interference fit. It will indicate the interference fit, and that small gs to en, it will indicate the transition. Then tell me what is the type of this fit?
Interference.
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 Interference fit. Okay, so I will take next example. Capital M7 and small h. Then tell me.
Clearance.
Clear.
Yes.
Clearance.
Transition fit.
Yes. काय कुठलं फिट असेल? इथं तर कुठला आहे ट्रान्झॅक्शन? हा, इथं कुठलं लेटर आले? कॅपिटल एम आले. कॅपिटल एम आले म्हणजे इथं आहे का कॅपिटल एम? ए टू एच मध्ये नाही. कुठे आहे कॅपिटल एम? इथं आहे. डायरेक्ट कॅपिटल एम ला आपल्याला माहिती आहे ना काय ट्रान्झॅक्शन फिट. So this is the transition fit. Okay.
Yes, sir.
Then tell me P7/H6, capital P and small h. Then tell me,
Interference fit.
Interference.
how it is interference fit?
Capital P lies between P to Z.
Yes, it is the interference fit. Okay, so understood. If such condition is there, then tell me, if 20D7 slash small k9, then tell me,
Transition.
it is a transition. How it is transition fit? How?
D is in between A to H. So
Barabar.
hence we have to go towards small
This side.
letter K.
Okay, and that G is lies between. Sorry, K na? K
Yeah.
is here.
K.
Okay.
And K is lying between transparent.
Which bit? Transition. Okay, so understood.
Yes, sir.
Yes, sir.
This is the one technique. Okay, so then what is meant by that IT grade? What is use of that IT grade? That point we will discuss on that numerical. Okay, we will take one to numerical on that also. In that manner also we will find out the types of the fit. But it is the very simple techniques. Okay, for the MCQ purpose I have explained here. That technique you have to remember. Okay, so can I take one to example here? Then tell me. Okay, just I will write down the example. You have to tell me. 20E7 slash small m8. Then tell me fit of types of the fit here.
Transition fit.
Transition.
Transition fit.
How you have identified? How you have decided this?
E because E lies between A to H.
Okay, E slash m. Okay, small m. E is lies between that A to H, so that to select the fit we have to go to this side. And we have to check where that m is lies. That m is lies small m is that between in this, and for that small it is the transition fit. Okay, so take next example. Tell me 30x7 slash small m9. Then tell me,
Interference fit.
it
Interference
is the
fit.
interference.
Interference.
How it is interference fit? Just check the capital X and small m. That capital X is not lies between A to H, so that it is necessary to go this side. It is
No.
not necessary. So directly we have to check where that capital letter is there. That capital letter is lies between P to ZC, and for this we are having the interference fit. Okay, understood?
Yes, sir.
Yes, sir.
Just then tell me.
Sir, can
Huh.
we take one example without trick?
Yes.
Without trick घ्या ना सर एक.
Means what? Without?
Trick ही जी trick आहे ना
That
तशी ती न वापरता.
That point already I explained. Na? I will take in that next lecture. I will take that numerical. I will take that grade.
Oh, okay. Sorry.
It is for your understanding purpose, and that exam purpose I have showing you these techniques.
Yes, sir. Yes.
Because this technique in exam they will directly ask MCQ question, identify this bit. Then it is in that exam you are solving this problem. Okay, for this purpose only I have explained the techniques. Okay, that point also we will take. Okay, so understood?
Yes, sir.
Yes, how to use this technique? This is the very simple techniques. You have to identify the fits. Okay, for the MCQ purpose, this technique is very simple. Okay, so understood this technique?
Yes, sir.
Yes, sir.
Okay, so okay, so thank you. Just I will revise the point, whatever point we have taken. Okay, in that lecture we have covered the fit. Okay, what is meant by the fit? It is nothing but it shows the tightness and looseness between two parts. It having three types: clearance fit, then interference fit, and yes, transition.
Transition fit.
In the clearance fit, what is the condition? Tell me conditions. Yes, In the clearance pit, shaft it will be the small, and
Small,
hole it will be the
bigger.
in the interference pit.
Shaft greater and
Shaft it will
Hole
be the
is
greater
small.
and hole it will be the smaller.
smaller.
And here overlap, both the are overlap. So this is called as the interference clearance pit. Then we have seen here hole basis system and shaft basis system. Okay, hole basis system and shaft basis system. In that hole basis system, where fix the size of we're fixing the size of
Hole.
Hole.
hole, and here again we are varying the size of shaft up for achieve the various speeds. And important point is in the whole basis system, the
Lower
lower
deviation
deviation should be
Should be
zero.
zero.
And in that shaft basis system, okay, the size of shaft is kept a constant, or fixed, we can say that. And we can vary the size of
hole.
Hole.
hole, vary the hole size, and
Upper
the
deviation
Upper
zero.
deviation.
upper deviation should be zero. Okay, and generally which system is prepared here? Okay, the whole basis system is
Whole
generally
basis
prepared for the mass production, because in that whole basis system we can easily vary the size of shaft with the help of the turning and grinding processes. Okay, and also we have seen the techniques to how to identify the pits. Okay, so after that, any doubt, any problem is there? Yes, anybody? Okay, so we'll stop here. Thank you.